Hello, this is Mr. Reynolds, and we want to learn about the eye today, and that's what we're going to do. So, moving on, we'll be coming back to this picture in a little bit, referring to the eye. And I just wanted you to see some things right now about it. There's a lot of gel in the back of it that gives it its shape, and that's the vitreous humor. It's a clear gel, and we need it clear, just like a window. We need the light to pass through that. So actually, this is pretty cool. This cornea, this outer window, in a sense, the cornea. It's the only tissue in the body that doesn't have any blood vessels. Okay? So if the cornea gets scratched, that's why someone might have to wear a black patch over, because it takes a little longer to heal. Okay, but we need it clear so the light will pass through the cornea, through there's fluid here in this anterior chamber called the aqueous humor. The light needs to pass through that. It needs to pass through the lens. Okay, there's a little bitty opening in that. Then it needs to pass through this clear gel. Once it comes through the lens, it usually gets um, bent down to a certain place where it's going to hit on the retina. Oh, actually, I see it up here. It's going to be bent up this way, and hopefully it's hitting right where there's a ton of cones for color vision, right here in this one little spot called the macula. Okay, all the rest of the retina has a lot of what we'll see structures called rods for black and white vision. Okay, the colored part of the eye is the iris. Some people have blue eyes, some have brown eyes, and some have green eyes, and that's because the color of this of the iris, which is part of a structure we'll call that'll be known as the ciliary body, or this dark layer, the choroid coat. Okay, makes up all of this. The pupil is just this opening here. It's not really a structure. It's just that opening between the irises. Between the iris. The iris goes all the way around. So it's the opening. When in the at nighttime, where this opens up a lot more, the pupil is a lot bigger. When someone turns the light on in the morning, a whole bunch of light comes flooding into this large opening, and man, it hurts. It's called the pupillary reflex. It takes about 20 seconds for it to get back smaller, for it to constrict, and us to get a small opening there, just allowing some of the light through. Okay. Now, well, we'll be. Okay, if this is another cool thing about the eye, if this is the left eye and this is the right eye, it's neat how it tracks up to the brain. Okay, with us, with our eyes in the front, and we see one image. Well, it's not set up that way. The brain has learned to do that. If you cover your right eye with your hand or something, and you see out of your left eye, all that is tracking up to the right visual hemisphere. Wherever the vision centers are in your brain, it's over on your right side. Pretty cool. Okay, if you do the opposite, if you cover up your left eye, anything that you see with your right eye, it tracks up and it goes to the vision centers in your left hemisphere. So you're actually seeing two different images, and your brain learns to put it together as one. And where these things cross here, this is called the optic chiasma. Optic chiasma is where they cross. So we learn to see only one image. I like green, backwards, stop. Another cool thing about the eye, another thing that we'll see is uh, uh, it looks a little bit different. You see this, okay, here's the ciliary body, okay, on each side of it, and then it's attached to, or they'll say ciliary muscles, and these fibers are called suspensory ligaments. We're going to write that here. It's not here on here. Suspensory ligaments. And the relationship between these is a little bit different. The lens that we see here, the lens of the eye, Well, for right now, we want to, if you're looking off in the distance, which you can, do all day long, because the ciliary muscles are relaxed, okay? And these ligaments end up tightening up, and it pulls on the lens a little bit to flatten it out, okay? And we can do that all day long because the muscles are relaxed. So this is for looking off in the distance, okay, a distant object. For looking at one that's near, it's kind of the opposite. We can only read for so long. If we're reading a little bit too long, man, our eyes start to hurt because those muscles start to wear out. But if we're looking at something close up like reading, these ciliary muscles are contracting, okay? And when they contract, these ligaments loosen up some. And the lens takes more, it bulges a little bit, takes more of its natural shape. And that's for us to see close up. Except the problem is these muscles are working pretty hard, so they're going to fatigue out and the eyes get sore. If we're looking at, the muscles get sore, eyes get tired if we're reading, okay? We can look at something in the distance all day long, all right? Okay. Okay, here's the last slide, but what we want to do mainly is to get used to some of these structures, okay? Like I said, we said the outer clear window, outer clear layer of the eye is the cornea, okay? It's the only part of the body that is that has no blood vessels, okay? And it must heal for it needs oxygen, but it's not carried by blood. It's going to get the oxygen directly from the atmosphere, okay? It's the only tissue in the body that does that. One thing that's not shown, I'm going to change color here. Let's go light blue. Around the cornea, on the outside of it, a thin layer, you'll see on some other eye diagrams, that's called the conjunctiva. All right. And I think oh, hey, there it is up there, okay? The second year I was teaching, seniors came back from spring break, and one after the other, they started to get pink eye. So conjunctivitis, I-T-I-S on the end of it after the V, conjunctivitis is pink eye, okay? It's a very contagious bacterial infection, okay? This aqueous humor, okay, this front section of the eye, in front of the lens, okay, in front of the lens is called the anterior chamber, okay, I'm sorry, anterior cavity. It makes a difference. A couple other things are called chamber. So in front of the lens is anterior chamber. Behind the lens, everything behind the lens is the posterior chamber. Posterior cavity. Okay. The posterior cavity is filled with there's some vitreous bodies. Mainly, we're concerned with the vitreous humor that's present there. It's the clear gel. Okay. In the anterior cavity, mainly the substance is mainly aqueous humor. Okay, and that is a watery, clear fluid that's present in the anterior cavity. And we're going to say the cavity that even includes back here behind the iris, okay? All right, that's part of it also. So this clear gel on this. And we label, you heard ciliary body before, suspensory ligaments help to suspend the eye, and you know there's some there's a relationship between ciliary body, suspensory ligament, and the shape of the lens that we said was accommodation. We'll go back over that some tomorrow. Okay. The lens of the eye, now this is cool in a dissection. I'm hoping I can find a way to show you that with the camera I have. But if you squeeze here on the back of the eyeball, it just pushes this out. This is not a strong connection between these ligaments and the lens at all. It's enough to help change its shape, but doesn't really hold it in position all that well. Okay. Layers of the eye. The white of the eye that you see from the front, the white of the eye is called the sclera. Okay. In the front, it changes to clear where it's cornea, and it loses the whiteness. We want it to be completely clear for the light waves to come through. In older days when they did battle, they had the one-shot muskets, and they would pretty much say, don't shoot until you see the whites of their eyes. Okay, that's the sclera. Okay, a choroid coat is the dark layer of it. Okay, that's the second layer, the choroid coat, and the innermost layer is the retina, and this is where all of the sensory cells are, and they're either rods for black and white vision, or they're cone-shaped, like an ice cream cone. They're cone-shaped for color vision. Okay, C and C. Cones are for color. Okay, the optic nerve comes into the back of the eyeball. It's also the one that tracks up to brain. This is sensory only. Sensory for vision only. Like I said, if you get something in your eye and it hurts, that's not the optic nerve. That's facial nerve being stimulated. Okay. Where this optic nerve comes in, okay, it kind of takes over any of these sensory cells right here. There's no rods or cones here, so if light hits here, you're not going to see anything. That's another name for this. So this is also called the blind spot. Okay, if light hits there, you're going to see nothing. It will not form any images. There are no sensory cells here. Okay. Since it takes a lot of energy making cones and keeping those, it's for color vision. Well, that doesn't really help at night because we need a lot of light to see in color. It's this area right in here called the macula. Okay, the macula. It's very, very heavily concentrated with cones. All right. The rest of the retina, all the way rest, I'm going to change this to purple. Okay. We'll notice when we dissect it, well, it's a deep dark color. It's almost black color. But the rest of the retina is primarily going to be rods. We're going to find a whole bunch of rods on the rest of these. So that's why if, like at night in your room, the light's been out for an hour, so your eyes have adjusted some. They say if you look straight at something, you don't see it as well, because when the light rays come in, it's going to get bent a little bit and head over to the macula and stimulate a bunch of cones, but you need a lot of light for that. They say if you turn your head sideways and look out of the side of your eyes, when the light rays come in, they're going to get bent, they're going to hit somewhere else on the rods, and you're actually going to see a better image because we've got more rods than we do here in this area, you know, with the macula. So you can actually see the image better in a dimly lit room if you look out of the side of your eyes. Okay, and that's all.